Welcome to Spring LIB.
So in first part of this problem, we have to write out a balanced chemical equation for the Ugi reaction. So here is the Ugi reaction, and first we look for if we have all the species in same number in both side of the reaction or not. So if we have all the species in both side of the reaction is same number, that means the reaction is already balanced and we don't need to balance it. And we'll make sure that by counting each species on both side uh, of the reaction equation. So we will start with um, this one here. So we'll start with the R groups, which is the hexyl groups. So in reactant side we have one R1, we have one R1 in the product side also. We have one R2 in the reactant side. We have one R2 in the product side. Then here we have one carbon which is bonded to R1 and R2. Here we have one carbon. Then we will look for the oxygen here. We have one oxygen here. We can just consider um, this oxygen and that one. Then we have R3 group in the reactant side, and we have R3 in the product side. Then we have R4 in the reactant side, we have R4 in the product side. Then we have one other oxygen here, we have one other oxygen here in the product side. Then we have R5 here in the reactant side, we have R5 in the product side. Then we have this CN here, we have CN here. um we have one other carbon here, we have one other carbon here in the product side also. Here we have one more nitrogen, we have one nitrogen here. Now what we have is we have two hydrogen here and a OH group here. So from two hydrogen we have one hydrogen here and one hydrogen from here with the OH group here. We have H2O here, where we have two hydrogen, one oxygen. Here we have two hydrogen and one oxygen. So that means we already have all the species which is present here in same number in both side of the reaction equation. That means this reaction is already balanced and we don't have to um, make it in a balanced state anymore. So the reaction equation we have, that is already balanced. Now in the second part of this problem, we are asked to find out the mass of the hexyl Ugi product if we are given the RNH2 group as 435 milligram, and if this is the limiting reactant. So what we will do first is we will find the number of moles of RNH2 group for 435 milligram of RNH2. So here once again, so the group here we are given is CH3, CH2, 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 um, and then NH2. And we can write it as RNH2, where R is the hexyl group here. So we are given the mass of uh, this compound has 435 milligram. That means we can write the mass of our NH2 as 435 milligram, or we can write it in grams by multiplying this. 1 gram is 1000 milligram, and this will give us 0.435 gram RNH2. Now we will find the number of moles of RNH2. So number of mole of RNH2 will be equal to the mass of RNH2, which is 0.435 gram, over the molar mass of RNH2. So we can calculate the molar mass from this formula here, and that will be, so here we have 3, 4, 5, 6 carbon. So we can write the molecular weight of RNH2. So we have carbon, so the carbon's molar mass is 12.01. We have 6 carbon. Then we have 3 plus 2, 5 plus 2, 7 plus 2, 9 plus 2, 11, 13 to 15. Total 15 hydrogen. Hydrogen's molar mass is 1.08. We have 15 hydrogen. And then we have 1 nitrogen, which has a molar mass of 14. So this will give us a value of 101.18 gram per mole. So this is the molar mass of RNH2. And if we just put this value under the mass of RNH2, it will give us um, the number of mole of RNH2, which will be 0.0043 mole. So this is the number of mole for 435 milligram of RNH2. And this is the number of mole of RNH2 which we are using in the Ugi reaction. And since this is the limiting reactant, that means the amount of the product will depend on this number of mole. And as you have said that, so in the Ugi reaction, this is our RNH2 group, this one. So from here you can see that since we have 1 mole of each reactant, which is producing 1 mole of each product, that means 1 mole of RNH2 can give us 1 mole of the Ugi product. That means 0.0043 mole of RNH2 will give us the same number of mole of Ugi product. Now we are asked to find out the mass of hexyl Ugi product. That means the hexyl groups here are the R groups, and here we have 5 R groups in the Ugi product. 1, 2, 3, 4, 5. So you have 5 hexyl group in the Ugi product. That means in the Ugi product, we will have this much mole times 5 mole of hexyl Ugi product. So the number of mole of hexyl Ugi products, if we just term them as R, so the number of mole of R or hexyl Ugi product will be 0.0043 mole, which is the number of mole of RNH2, and also the number of mole of Ugi product which is being produced. And since in 1 mole of Ugi product we have 5 mole of hexyl group, so this in this much mole of Ugi product we will have this much mole times 5 mole of Ugi hexyl Ugi product, and it will give us a value of 0.021 mole. So this is the number of mole of hexyl Ugi products. Now from here we can find the mass of hexyl products. The mass of hexyl product will be the number of mole of hexyl product times the molar mass of hexyl group. Again, hexyl group has um, C6H13, which you can see from here. So in this RNH2, if we just remove this NH2 group, that is our R group here, or the hexyl group. And here if we count, we can see that here we have six um, we have 6 carbon and 13 hydrogen. That means, and the molar mass of this, if we calculate, we will get a value of 85.164 gram per mole. So if we multiply the number of mole of hexyl product by the molar mass of hexyl group, which is 85.164 gram per mole, it will give us a value of 1.79 gram of hexyl product. So this is the mass of the hexyl product that will be produced if we are given with 435 milligram of the RNH2 group as limiting reactant.